All right, so we're working on linear inequalities, and so just a quick review. If you have an inequality and if something is a solution, then that means it makes the statement true. Okay, so we looked at this with equations yesterday, and now we're going to look at inequalities. So we substitute 3 in for x, 4 times 3, and we ask ourselves, is that greater than 11? Well, 4 times 3 is 12. 12 is greater than 11, so that is true. So that means it's a solution. Okay. Number 2, 16 is greater than or equal to 4y. Y equals 4, so we replace y with 4. And then we ask ourselves, is 16 greater than or equal to 4 times 4, which is 16? Well, 16 equals 16, so that is true. So it is a solution. Okay. X equals 0, so 17 times 0, is it greater than or equal to 15? Let's see, 17 times 0 is 0. 0 is not greater than or equal to 15, so that is false. So not a solution. Okay, and then negative 7 times 6, is it less than 9? Well, negative 7 times 6 is negative 42, which would definitely be less than 9. So that is true. So it is a solution. All right. Solve the literal equation. A literal equation is basically an equation with 2 or more variables in it. Okay? So we're going to solve it, and this is what we were doing when we said we would solve for y, right? But in this case, we're going to solve for x. So I look at all the places I have x in the equation, and I want to only have one of those. Okay? So first I look and see, is there something I can do to make that one term? Well, 3x minus 9x is actually the same thing as negative 6x. So y equals negative 6x. Now I just have one x term. So I want it to be by itself because that's the solving process. Solve for x, get x alone, isolate the variable. Okay, so we'll divide by negative 6 because negative 6 divided by negative 6 is 1. But I have to do that on the other side of the equal sign. You might want to do your little line down the middle on that. Okay, when I divide y by negative 6, there's an understood 1 here, so I would write this as negative 1/6 y equals x. So I've solved that for x. Okay, now on this one I only have x in one place. Okay, so when I solve for x, I'm going to get everything around all that's here, the 86 and the 59, to not be on that side of the equation anymore. Okay, so I'm going to draw my line down the middle at the equal sign. Okay, I'm going to add the 59 because I know adding 59 will make 0. So I add 59 on the opposite side. Okay, so I have c plus 59 because c is a variable, 59 is a constant. I can't combine them. And then I'm left with 86x on the right. So I divide by 86 because 86 divided by 86 is 1, leaves me x, and then I divide this side by 86 as well, each of the terms. Okay, so equals x, that's what I have left on the right side. C divided by 86, we still have that understood 1, so that's 1 over 86 c plus 59 over 86. Ta-da! We have solved for x. Nice! Alright, let's see what else we got in this little packet. The essential question for today is, how can you graph a linear inequality in 2 variables? How can we graph it? Okay, so we're probably going to see some grids, right? Let's see. First, though, it says, tell whether the ordered pair is a solution of the inequality. Well, that doesn't seem to have anything to do with graphing, but let's go ahead and take a look at these. If it's a solution, when we substitute the numbers in for x and y, then we should get a true statement, just like we did on the first slide. So 2 times negative 1 plus 9, is it less than negative 3? 2 times negative 1 is negative 2 plus 9. Still wondering, is that less than negative 3? Negative 2 plus 9 is 7. Is 7 less than negative 3? No, it is not. So that is false. Okay, so not a solution. All right, let's try the next one. X is 2, y is negative 2, so we're going to replace x with 2 and y with negative 2, and we're going to find out, is it greater than or equal to 8? Okay, so 2, and then minus 3 times minus 2 would be plus 6, greater than or equal to 8. 2 plus 6 is 8. Is 8 greater than or equal to 8? Well, it is not greater than, but it is equal to, so that makes this statement true. And so 2, negative 2 is a solution. Okay. Let's see what this has to do with graphing, though. I'm a little confused. All right, let's see. It says, if we're graphing a linear inequality in two variables, the first thing we're going to do is graph the boundary line for the inequality. Use a dashed line, okay, so that looks something like that, right, dashed line, for less than or greater than, and then use a solid line, so something like that, right, for less than or equal to and greater than or equal to. Test a point that is not on the boundary line to determine whether it is a solution. Okay, so that's what the previous two were about, right? We pick a point that's not on the boundary line and we see whether or not it's a solution. Okay, so when the test point is a solution, we shade the half plane. Half plane. I don't know that I've ever seen that word in our course thus far. A half plane. Well, I think that refers to the fact that when you graph a line on the coordinate grid, right, you're going to cut the plane in half, right, the coordinate plane. And so you're either, when you're shading this side, that would be the half plane, or you could take the same line and be shading below the line, which would be this half a plane. Okay, so we'll shade the half plane that contains the point. Okay. So that's if it was true. If it's not true, then we shade the other side. That's what that's saying. Okay, so let's put one into action, shall we? Okay, so we're going to graph y is less than or equal to 2 in a coordinate plane. Okay, so y less than or equal to, that symbol they told us previously would be a solid line. Okay, and we need to graph like it's y equals to, only difference would be if it wasn't a solid line, we'd do a dashed line in the same place. Okay, so y equals to, we remember, is a horizontal line through 2, because there's no x value, which means the slope is 0, and 2 is my y-intercept. Okay, y is 2. So I'm going to do a solid line here through 2. Okay. All right, put my little arrows on the end because the line's going on forever. Okay, now then, it said to test a point not on the line. So 0, 0 is not on the line. Would you agree? I hope so. So here's 0, 0. So that means x is 0 and y is 0 on that point. My equation only has a y in it, so I would substitute y with 0 and ask myself the question, is 0 less than or equal to 2? Yes, it is. That's true. Okay, so I shade where that point is. So I'm going to shade here. Lots of shading. Okay, so that whole section is shaded in. Okay. Okay, negative x plus 2y is greater than 2 in a coordinate plane. Okay, so first off, this symbol is going to be a dashed line. I know that. Okay. And I also know that one of the ways that we've graphed is when it's in the standard form, right? We solve for y. So I'm going to do that. Negative x plus 2y is greater than 2. Okay. There is one little thing that I need to bring up at this point. When we start solving inequalities, there's one thing that makes them different from equations, and that is if we ever divide, okay, so this should be a special note, right? If we ever divide by a negative number, and actually it's if you divide or multiply by a negative, then you flip the inequality. Okay, so for instance, if I had negative 2y was greater than x, okay, now this has nothing to do with the problem up here, I'm just making something up, and I wanted to get y by itself, I would divide by negative 2, right? Well, since I'm dividing by a negative, I'm going to flip, so instead of being greater than, it will now be less than negative 1/2 x. Okay, so that's the only tricky part of inequalities you got to pay attention to. If you flip that symbol, if you divide by a negative, you're going to flip the inequality. Okay, so let's go ahead and solve this one. To get y by itself, we would add the x, and so again, just like with when you have the equal sign, you're going to drop a line down the inequality symbol, and so we'll add x on this side. So I now have that 2y is greater than 2 plus x. I did not multiply or divide by a negative, so I kept that greater than. Now I would divide by 2 to get y by itself, and then I would divide each of these by 2. Okay, again, not a negative, so I leave it alone. Y is greater than 1 plus 1/2 x. Okay, so I come over here to my grid, and I begin at 1, and then I have a slope of 1/2. So up 1 to the right 2, up 1 to the right 2, and so on. Or I can go the other direction, down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Because of this symbol, it is a dashed line, so we're just going to do a dash. Okay, put our arrows on. Okay, now we want to check a point that's not on the line. Again, 0, 0 works really well because it's right there. So this would be negative 0, which is no such thing, but okay, plus 2 times 0 is greater than 2. So this would be 0 plus 0 is greater than 2, which means 0 is greater than 2. Is that true? No, it is false. 0 is less than 2. That means we do not shade down here, we shade up here. Since it was false, we shade on the other side of the line. All right. Now look at writing a linear inequality. Okay. So the explanation here says if the shaded half plane is above the boundary line. So we're looking at, here's my boundary line and my shading's here. Here's my boundary line, my shading's here, right? But it's above the boundary line. Okay. Then we'll use these two symbols, which are our greater than symbols, and we'll use strictly greater than when it's dashed, and we'll use greater than or equal to if it's solid. And then the opposite of that, when it's below, right, then we'll use less than or equal to. We'll use less than when it's dashed and less than or equal to when it's solid. which this little chart right here kind of will help you pick out which symbol to put in. Okay? All right, so we have a solid line. We are shading below the line. I know it's below because we're going down, right, from the y-axis. We're going down the y-axis. So we would want to use a less than or equal to, because solid and shading down. Okay, now we're going to put a y here because our lines, right, are y lines. And then we have to, we're going to use our mx plus b form. Right, M and B. So we find out what is B. Well, that's easy. It's -1. So I'm going to put -1 in that spot. And what is M? Okay, well, from this spot, the next time it goes through the corner is here. So I'm counting, I'm rising 2 and running 1. Okay. So, and my line is going down, so that means it's a negative slope of 2 over 1. So then I clean that up a little bit and say y is less than or equal to -2x minus 1. Okay, let's see what else they got for us. An ice cream truck can carry at most 75 gallons of ice cream. The table shows the inventory on the truck. Write an inequality that represents the number of gallons of strawberry and banana ice cream on the truck. Okay, so here strawberry is X, banana is Y, and all of this is going on the truck, right? So we have 20 plus 15 plus X plus Y plus 18 is all going on that truck, which can be at most 75 gallons, at most. So at most means it could be less than 75 or it could be exactly 75. But it can't be 76. That would be more than 75. So that would be too much, okay? So less than or equal to 75. Okay. Then we would want to clean that up a bit because 20 and 15 and 18 we could add together and we'd get 53. So we have X plus Y plus 53 needs to be less than or equal to 75. Okay. We could take that a step further and subtract the 53 from both sides so that we just have the one constant number. So X plus Y is less than or equal to 22. Okay. And then if we were really feeling like, oh, we really want to push ourselves, we could rewrite the inequality where Y was by itself, right, by subtracting the X from both sides. So we'd have Y is less than or equal to 22 minus X. Okay. All of those are answers. I probably would have stopped here. That's probably the best choice for given the situation. Or here, because that would be something I could graph and work with as well. Okay. You can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound, so grapes are $2.50. Apples cost $1 per pound. Write and graph an inequality that represents the amount of grapes and apples you can buy. Identify and interpret two solutions of the inequality. Ooh, they don't want much, do they? Okay, so let's think about this. Let's let G stand for pounds of grapes. And we'll let A stand for pounds of apples. Just to keep it simple. So then I know that the grapes times 250 is going to be the money I'm going to spend on grapes. So that'd be 250 times however many pounds of grapes I have. And then my apples will be $1 times the number of apples I have, pounds of apples. Okay, and then if I add those two together, they can be at most 10. So again, at most means I cannot spend more than 10, so I'd use less than or equal to. Okay, so there's my inequality, and now they want me to graph that inequality. Okay, well, not giving me a lot to work with there, but if I've got grapes and apples, right, I know neither of these is really dependent on the other, so I can kind of pick between grapes and apples. I'm just going to put grapes here because it was written first, and apples here because it was written second. There's no other, there's nothing to guide me on that one. So, all right, I know it's going to be a solid line when I graph it because of the symbol that we used. Let's see. Here's something. If I just bought grapes, no apples, okay, that would be 0 apples, then that would mean 250 grapes, right? Less than or equal to $10. I can't spend more than $10. So if I then divide that by 250, then that means that my pounds of grapes would have to be less than or equal to, let's see, 10 divided by 250 is 4. So I'd have to have less than or equal to 4 pounds of grapes. So that would be 0 apples. So that would be my y-intercept, right? So 0 apples, 4 pounds of grapes. Okay. Likewise, if I chose to not buy any grapes, just apples, then 1a would be less than or equal to 10, and I would divide by 1. So a would be less than or equal to 10. So at most I could buy 10 pounds of apples. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pounds of apples. And it's going to be a solid line through there because of the symbol, less than or equal to. So we're going to connect them with the solid line. Okay, now then we have to deal with the shading issue, right? Where do we shade? Do we shade above that line or below that line? Okay, well, let's think about this. If it is less than 10, where are the numbers less than our line? Well, they'd be below, right? So that would be, we would shade under our line. Okay. And I'm just showing this as a first quadrant graph because you're not going to have negative apples and negative grapes. That just doesn't make any sense. Okay, so we've got it graphed, and now they want us to identify and interpret 2 solutions. Okay, 2 solutions would have to be in our shaded area. All right, what if I pick a point, say right here? That would be a solution because it's in the shaded area. And that is at 1, 2, 3, 4, 5, 6, up 2. So that would be 6, 2. That would be a solution to my inequality. And what would that mean, right? Because it says identify and interpret. Okay, so that would mean I had bought 6 pounds of apples and 2 pounds of grapes. So that's my interpretation of that solution. And if I picked a point, say here, it appears to be 2, 3, then that means I bought 2 pounds of apples and 3 pounds of grapes. So I can, anywhere in this shaded area, any combination of apples and grapes that I get from picking in the shaded area or on the line itself, because since it's a solid line, right, that would be a solution, any of those combinations of grapes and apples would be less than or equal to $10 and would fit the situation that they gave us. Okay, so now it's your turn to do some work.